Hey, chapter 14 is on flexibility training concepts. A lot of good material here. And again, seventh edition of the NASM Personal Training Certification textbook. As always, remember to have some paper. You're going to need to take a lot of notes. And I will say this, that there's a lot you can also draw out and kind of write out conceptually to help you to memorize some of this information. Kind of the idea is that in chapter 14, they have given you, before you even get to it, I'm just going to go ahead and kind of preempt it for you, that there's a fair number of tables. And as you get through towards the end of the chapter, they are going to provide you with just a whole bunch of pictures of the different types of stretches that are available to do. So even though chapter 14 appears to be pretty thick, lots of pages in there, in reality, it's not a whole lot of written material. There's lots of pictures and figures to show you some of the numerous stretching exercises that are out there. And so as you go through it, read through the technique. But the most important thing when it comes to these, as we go through the chapter itself, is just look at the stretch, know the name of the stretch, and for the most part, just understand what that particular stretch, what muscles it's trying to relax through this process. So again, chapter 14 on flexibility, training concepts. A nice thing about this chapter, it's going to give you a little refresher on the human movement system. And so we're going to go over a couple of terms that you should have already worked through and memorized in some of the previous chapters. Flexibility has a specific definition. Extensibility is going to be a part of that. Range of motion, all of those are going to be a part of that. Mobility, these are terms that you do need to memorize. And so flexibility itself, irrespective of what you heard or what you think it is, it's actually defined as the normal extensibility. You got to think about it this way. Muscles, for the most part, and soft tissue, for the most part, really only move in one linear direction, right? Muscles, you don't pull muscles apart. They essentially lengthen and shorten. So that's a single linear direction. So they will lengthen and they will shorten. And there is an extensibility component to muscle and the fascia and all the other soft tissue that is a component of the entire muscle itself. So there's a lot of stuff inside a muscle, not just the myosin and actin myofilaments, but there's fascia. So fascia is made up of collagen and elastin, and there's other components to the entire muscle that make it a fairly complicated structure. And so one of the reasons why flexibility training is so critical is because it can actually overcome and assist with some of the distortion patterns that we already spoke about. So one of the things I'm going to do is I'll draw a little bit for you. It helps to kind of visualize what we're going through. So flexibility itself has a number of variables that are associated with it. And on page 439, there's your list. So genetics, whatever, that's a sort of a general term to say all the other variables that we really don't know, but are related to a person's height, weight, and other issues within the muscular system. Myofascial tissue elasticity is another factor related to a person's flexibility. Composition of tendons or skin surrounding the joint. Okay, so depending on your the relative tautness, it can actually affect flexibility or overall range of motion. Joint structure. Different joints have different relative flexibility attributes about them, and the individual joint, the laxity or the tautness of the joint capsule. So if you think about it, there's a lot of things that go into just trying to move the elbow through its range of motion, right? There's the tautness of the skin around the joint. There's the components, elements within the joint. There's a capsule. There's a very strong band-like encasing around the joint itself that ensures that the synovial fluid stays in place, hence the term synovial joint. But all of that's going to affect how well a joint moves within its effective range of motion. And of course, the goal ultimately is to get all the joints of the body, right, to move through their proper, healthy, normal ranges of motion. When that doesn't happen, it can lead to just chronic pain in those joints. It can also lead to injury. It's one of the reasons why flexibility training is so critical. So even something as you might not think about as esoteric as the strength of the opposing muscle, the ability to move a joint through its range of motion might actually be impeded by the opposing muscle, right? That has to lengthen to allow for the joint to move through its range of motion. By the way, that is going to be one of the critical variables that you're going to see as to why we do flexibility training. Body composition, age, sex, activity level, previous injuries. Of course, you can have adhesions that have built up in those soft tissue areas that were injured. You can have calcification in and around joints that will mechanically, physically limit the range of motion. You can actually even look at somebody with arthritis, for instance, where the joints have become mechanically inefficient due to the increased calcium in and around those particular joints. So then the fingers simply can't move as well as they should. And that's a mechanical issue. And that's due to basically injury to the joint, the arthritic joint. And then, of course, repetitive movements. So all of this comes together as we move into the human movement system review. But again, it comes together to help you appreciate that there are issues and problems associated with the human movement system because of the soft tissue dysfunctions that we literally just spoke about. Okay, so when muscles are shortened, they're overactive, and then they pull on the antagonistic muscle. That causes the joint to move into a inefficient position over an extended period of time. Now, if you try to extend, for instance, or get the elbow to move through an extensive range of motion, if the bicep was overactive and shortened, that's going to limit the range of motion because the extensibility of the bicep muscle itself has been altered or reduced. So you're going to see that term a lot, by the way, especially in this chapter, is this term altered. And so you might as well get used to it now. So the human movement system review, remember postural distortion patterns, the upper cross, lower cross, the pes planus, distortions that we talked about. Those are caused generally by muscle imbalances, right? That change the positioning of the skeletal system over extended periods of time, which leads to pain and discomfort, and then this altered length tension relationship. So here's a great opportunity now to do a little bit of a review. Muscle imbalance. What causes the muscle imbalance? Well, normally it's poor postural positions over extended periods of time. Really pretty simple. Normal, healthy people sit down a lot and allow their torsos to round forward, allow their pelvis to tilt back, forward, right? And then that causes, over time, muscles which are normally at an ideal length, right? It causes those muscles to either shorten, right, and alter their length, or lengthen into an altered length, right? Being a muscle that is too long or stretched too long does not have maximal overlap of the actin and myosin filaments within the sarcomere. Okay, so now you've got to kind of go back and rethink about the anatomy of the sarcomere and the muscle, and then you go, okay, right, the actin and myosin filaments, They have to have maximum overlap to create maximum tension, which creates maximum power. And if that's not the case, if the muscle is too long or the muscle is too short, that means that the sarcomeres are too short or too long. You're not going to have an ideal overlap of the actin myosin filaments. All that does is that brings us up to the macro level. And here I am sitting, and my psoas muscles and my rectus femoris muscle are too short. And because they are shorter than they ought to be, they're more tense. They're more tensed up than they should be. That's called overactive. And when they're like that, they now don't want to go back to their ideal length. The same thing with the muscles that I'm sitting. So my hips are in a flexed position, which means that the hip extensor muscles, right? Those muscles that are normally there, like the gluteus maximus, right? Those muscles now they're being lengthened. And because they're being lengthened and they are being pulled longer than they really want to be, right? They tend to get weak. They weaken and they become what's known as underactive. So then when I try to stand up, what ends up happening is I'm still not sort of bent over, that bent over position. I kind of have to, stretch this way, get up. You do it. And that's what we're talking about here. So a little bit of a review is helpful. Figure 14.3 basically shows you that muscle imbalances cause poor posture. It doesn't happen in one day. It happens over months and years. Poor posture leads to improper movement patterns. So here's something that we're going to discuss as well. Improper movement patterns over time leads to injury in some way, shape, or form. So there's your review. Force couple relationships. And I think it's probably a good idea if I give you a little bit of a visual on this to help you get an idea of what we're talking about. And let me go ahead and draw this for you. So first and foremost, if you remember, we drew a picture of the spinal column. I'm not going to go through that, but force couple relationships are important, and we normally see force coupling occurring at basically two areas. One is the scapula, and the other is at the pelvis, right? So force coupling, I'll just draw a circle, and this is going to represent the concept of force coupling. Now, if this circle that I have here is able to rotate, right? So I have a center area, and basically this circle, this disc is able to rotate, right? It doesn't move this way or that way, it just rotates. Well, the idea of a force couple is that muscles, right? Muscles on opposite sides, for instance, of this wheel, right? If the muscle shortens, it's going to pull this way, right? So if the muscle shortens, it's going to pull the wheel like this. Now on the other side, let's just say on the other side, I have another muscle. The muscles only move in one linear direction, right? And so if this muscle pulls, right, it pulls, it contracts and shortens this way. Well, what's this is going to do? Now it's going to pull this way. If this happens simultaneously, I hope you can see that the wheel turns. Okay, it turns this way. As these two contract simultaneously, they are pulling in opposite directions, but they produce a single unified movement. This happens at the scapula, for instance. Okay, so if this is the spinal column, the scapulae, both scapula, right, which are kind of shaped like this, and they have the glenoid, which is where the shoulder joint sits. This guy's up here. That is way different than that one, but pretend it's the same, please. So the scapula has muscles that are attached to it up in here, all through here, right? And there are muscles that attach to it down in this location, and the scapula can rotate. And the reason it can rotate is because you have muscles that pull in this direction, okay? and muscles that pull it over in this direction. So this can actually rotate back and forth. Now, the scapula can also move, right, outward, right, through shoulder protraction. And so the scapula can rotate this way and that way. And in fact, it has to allow for movement of the humerus when you're doing shoulder abduction. So literally the scapula, when you do shoulder abduction, right? If you lift your arm up and out to the side, past roughly 60, 70 degrees of abduction, there's not a whole lot more movement inside the shoulder joint. The actual continuation of movement of getting the arm up overhead occurs with rotation of the scapula. And then the scapula rotates like this, okay, to allow for continued movement of the humeral head. This is what we call a force couple relationship. It happens as well at the pelvis, right? Here's your legs, right? Your pelvis. The pelvis is able to swivel back and forth. Okay, fortunately, right? It can swivel back and forth, right? Because of force couples. You can see where my hands pulling, this simultaneous pulling contralaterally, right? Superior and inferior. Okay, it's a bit more complicated than that, but you get the idea. That's what's called a force. So it's called a force couple. So I hope that helps with explaining that. It's kind of challenging if you're not able to physically see it. And one of the reasons why it's nice to have like a skeleton or 3D model is because you can actually kind of move it around and see how it works. You know, force coupling is pulling down this way, simultaneously pulling up this way, right? So the muscles pull and pull, you have a force couple like that, okay? So it's very important in the human movement system for this to occur so that proper motion and movement patterns can occur. It requires a fair amount of synchronization between muscles. So always keep in mind that within the human muscular system, while certain muscles are contracting and shortening, other muscles, the antagonistic muscles, have to be lengthening, relaxing to allow for that appropriate movement to occur. So muscle imbalances, you've seen this figure before. Muscle balances occur again for any number of reasons, but normally muscle imbalances are going to occur because that is the effect, and the cause is the positioning of the skeletal system over extended periods of time. So there's no issue with my muscular system until I sit down for an extended period of time. And the more I sit down, the longer I sit down, there's going to be a chronic shortening of the hip flexors. There's nothing problematic right now, but if I do this for 20, 30, 40 years, like we see with sort of the average person, the muscles tend to adjust themselves to the position of the skeletal system. Okay. In other words, let me do this again for you because it'd probably be helpful. The and I showed this in another chapter, but the hip flexor muscles, just as a for instance, as long as the spinal column and the hips, right, are in proper alignment with the leg bone, with the femur, these muscles on this anterior side that flex the hip are at proper length. So it's not an issue with the muscles per se. But if I take this and now I sit for an extended period of time, what am I doing to the muscle? It's not the muscle. The muscle is now going to adapt itself to this shortened length. Okay, because I'm in this position, the normal stimulation of the muscle spindle fibers is going to start to move and keep the muscle in this shortened length. That becomes chronic. Okay, that becomes chronic. Because that becomes chronic, now the muscle becomes overactive. But it's not that overactive muscles pull joints into inappropriate positions. No, it's because we put our bodies into these inappropriate for extended periods of time. It's not inappropriate to sit, but in these positions that allow for the muscle to then shorten and stay in this shortened position. Because it stays there. Again, I've used the most obvious example of this is when you get a cast. If you break your arm and your arm is in a cast, right, like this, they immobilize everything. What happens when they take the cast off 6 weeks, 8 weeks later, right? We know this. Well, you got to go to physical therapy because what happens? You get it's called a frozen joint. The joint basically freezes. All of the muscles that are now shortened in that position, lengthened in that position, neurologically, they stay in there, right? The muscles are adapting to the positions that they've been put in. It is an extreme case, but the beauty of it is, what can you do in 2 weeks? Even less if you're doing your exercises. You can actually now start to reteach those muscles to start to deactivate the muscle spindles, right? And get them to get back to their normal physiological length. So that's the deal with muscle imbalances. And I can spend more time, of course, on it because in this particular chapter, flexibility training is based on this. The rationale for it, the reason we do it is because of this neuromuscular response and adaptation that occurs that we call muscle imbalances. So now altered reciprocal inhibition. Now there it is, altered. The concept of reciprocal inhibition, once again, probably better if I give you the visual on this. Reciprocal inhibition is the normal way agonist and antagonist muscles work with each other, right? So reciprocal inhibition, you can spell the rest out, inhibition is a normal neurological process that allows for one muscle, and again, I'll use the biceps and the triceps, there's the elbow joint, that allows one muscle, the agonist, right, the primary mover of a motion, right, that allows the agonist to effectively shorten, contract, and not be impeded by the antagonist, in this case, the tricep, okay? Here, tricep. In order for the bicep to shorten, the tricep needs to lengthen. Well, the tricep doesn't necessarily want to lengthen, just it's not trying to be offensive. It just has a normal tension. Well, we've got to override that normal level of tension that the tricep always has. When the bicep needs to shorten and contract, and the hand moves up like this, and the bicep shortens, right, and contracts, reciprocal inhibition is this neurological turn-off switch, right? The biceps essentially are telling the tricep, shut down, stop working, relax. Okay, let me do what I need to do. You stop working. That's called reciprocal inhibition. Okay, it happens anytime an agonist muscle needs to perform its function and the antagonist muscle needs to relax. So again, on page 443, it explains to you reciprocal inhibition is normal. It's the normal way the body functions when the quadriceps are going through a shortening process, right? When you're doing a squat, for instance, the quads, if they are contracting, there has to be a relaxation of the knee flexors, right? The hamstrings, for instance. And so reciprocal inhibition is always about two or more muscles, right? It always involves the inhibition caused by the activity of another muscle. So there's always two muscles, two or more muscles. Okay, obviously, There's synergists that are associated with this. So one muscle needs to work, like when I'm doing a dumbbell curl, my tricep needs to relax. There's a neurological impulse, okay, that tells neurologically the tricep to relax so that you can actually get the bicep to shorten. Same thing when you do a tricep. So if you do a dumbbell curl, triceps relax. If you do a tricep push down, right, now it's just the opposite. If the triceps are shortening, right, well, the bicep needs to relax. You do it yourself. Do a tricep push down with one arm. And as you're pushing down, go ahead and palpate your bicep, and you'll notice it's very relaxed to ensure that the tricep can actually work. So this leads us to what's known as altered reciprocal inhibition. So in this case, this is the proper functioning. That's the proper functioning of the bicep and tricep antagonistic agonistic pair. In altered reciprocal inhibition, when a muscle that we've been talking about, right, and I'm just using the bicep and the tricep, altered reciprocal inhibition is simply that there is an inappropriate, improper, extensive neural impulse from the agonist, which is overactive. This is not the way we want it to be. It's an overactive muscle. It's sort of hyper shortened for whatever reason, right, due to postural problems. But if it's shorter than its optimal length tension relationship, if it's shorter, it becomes overactive. So it's actually neurologically more active, and it shortens. Well, altered reciprocal inhibition is that now, because of this, remember what I said, the agonist sends an impulse. Well, it essentially sends an impulse. It has to go through the spinal column, and there's afferent and efferent the neurons that are involved with this, but we'll keep it simple. The tricep, which is already lengthened, continues to receive these inappropriate, like these word inappropriate, neurological stimuli, right? The normal stimulus is to relax, right? Lengthen and relax. But then it becomes a hyper neurological response, chronic. Over time, we call this altered reciprocal inhibition, and it's just an impairment of the human movement system. That's all it is. It should not be happening under normal, ideal, perfect conditions, but because of the hyper or over activity of the agonist, the antagonist is constantly pounded with this neurological impulse. It's actually to increase the activity of the Golgi tendon, but this continued pounding on the muscle, so to speak, from a neurological perspective, causes it to lengthen and essentially weaken, and we call that underactive. So you can see how all of these sort of work together, and I'll stay on here next because we're going to talk about synergistic dominance. The synergist, think of the synergist as Robin to Batman, right? Batman is he's the primary guy, and then Robin is his, his helper, so to speak. Well, for the most part, and this happens predominantly in the pelvis and the shoulder region, but normally the way this works is that over a joint, and again, I'll just use the elbow, although, and it does happen at the elbow, by the way, but normally we see it at the LPHC. When the primary mover, right, and the primary flexor of the elbow, just as a for instance, right? This is the guy that normally does what he does. He's supposed to be doing this. Well, if there's an issue with this primary mover for whatever reason, what ends up happening is that the secondary or synergistic movers of that joint become the primary movers. So let's just imagine now we do have a muscle underneath the biceps brachii called the brachialis. So if the brachialis, for instance, is the synergist in a particular movement, we also have the brachioradialis muscle, right, which is also a flexor, but that's when the hand is pronated. If, for instance, the bicep brachii is the primary mover And these synergists now are taking over the primary function that this guy can no longer do for whatever reason. It's underactive, it's injured, whatever the case is. These muscles now are doing the job of the primary. Robin is not supposed to do Batman's job, is basically what we're saying. Synergistic dominance is exactly what it says. The synergists become dominant or become the prime movers. This more than anything, to be honest with you, is a huge problem, and one of the things we see quite often with LPHC, the lumbar pelvic region, this synergistic dominance of the hamstrings doing, for instance, what the glutes should be doing, or or the hamstrings, for instance, doing what the adductors should be doing. It's really pretty interesting. And what you're going to have to do is, as you go through this, you got to memorize. You've got to memorize basically the muscles and their synergist. Just like with everything else we've talked about, if you understand the function of these, if you truly understand the function, it's not that difficult to kind of figure out, well, if my femur is externally rotated, stop for a second, okay? Don't think about memorizing muscles just for the sake of memorizing. But if you know, there's probably about, I don't know, 15, maybe 20 muscles that you really need to memorize. But if you know that the TFL or the the semitendinosus or the biceps brachii, long head, are dominant, but you know darn well that the main external rotator of the femur, for instance, is either the gluteus medius or the maximus, depending on the position that you're in. Well, then you can pretty much figure it out that those guys are going to be they're going to start to create problems, and they're going to pull in the wrong way over time. Remember, in synergistic dominance, you can get the movement done, but it's not going to be done in the most ideal, efficient way. And that's the problem with synergistic dominance. It's a very insidious neuromuscular problem. We go years and decades even with these issues. It's one of the reasons why we see injuries. I've trained with athletes who have compensated so well for their synergistic dominance. They've compensated for years so well, but then when it's time to really move forward in their training, they get injured. And it's simply because their prime movers, their glutes, for instance, which are it's a primary muscle in particular movement patterns, because those guys, because of poor posture, are not doing the primary movement, but you have synergists that are now taking it over. Number one, you don't have the same power output, because synergists are generally just not as powerful as the primary mover for a particular movement. So again, synergistic dominance, you've got to know the issues that are related to the particular muscles and their synergists. If you know that, if you can memorize primary movers and joint functions and their synergists, boy, you are well ahead of the game with knowing this stuff. So altered length tension relationship, we spoke about neuromuscular efficiency. Now we get into the mechanoreceptors, and the two main mechanoreceptors in and around muscles are the muscle spindle fibers and the Golgi tendon organs. The key here to remember with muscle spindle fibers is that they're always active. Muscle spindle fibers are always slightly active. They're always sending neurological responses to the spinal cord to keep the muscle under basic levels of tension. The term that is used is called tonus, T-O-N-U-S. And that base level of tension contraction is what keeps the muscles, in a position where they can go into a full contraction as needed. So the muscles have muscle spindle fibers inside of them. They tell the muscles when they get overexcited, when they get stimulated, they tell the muscle to contract. Fibers to kind of calm down, and that's really what we're talking about. Golgi tendon organs located in the musculotendinous attachment, in that tendon area between where the muscle fibers end, the tendon begins, and the bone. Those guys are really interesting because when they get activated, they shut the muscle contractile machinery down. In other words, they tell the muscle spindle to stop functioning for the most part. This is where it can get a little confusing. So let me again show you a little bit what this looks like. So in the muscle, you have muscle spindle fibers, right? These are small, what they call them intrafusal fibers, not necessary, but they're wrapped around by a nerve. And as the muscle lengthens and shortens, it sends impulses to the spinal column to kind of let the spinal column know, right? The nerve, the spinal cord know what's going on in the muscle. As the muscle lengthens and shortens, muscle spindle fibers become active and less active. Golgi tendon organs are located. This is where the muscle fiber basically ends. This is all tendon. The Golgi tendons are located right in here in this musculotendon. This is the bone. That's a problem bone right there. So the Golgi tendon organ is located inside this area right here. So when the Golgi tendon organ gets stimulated, it basically tells the muscle spindle fibers to reduce their activity. So think about it. What do the muscle spindle fibers do? They tell the muscle to stay tense or to contract. Well, if you have another piece of apparatus that can shut it down, it would basically tell the muscle to relax. So Golgi tendon organs work via the muscle spindle fibers. That's basically the idea. Autogenic inhibition, right? And you'll see this. So autogenic inhibition, remember the term, it inhibits, right? Autogenic inhibition occurs inside a muscle itself. Remember, reciprocal inhibition occurs in two or more muscles around a joint. Autogenic inhibition is always within a single muscle. It's the muscle's self-regulatory process of ensuring that you don't hurt yourself or you don't stretch and hurt that muscle too bad. So now that's important to understand because now we can use this information to do what? To affect flexibility training. Now that you know about the muscle spindles and the Golgi tendons and what they do, now we can put a plan together, so to speak. And that plan is going to involve getting the Golgi tendons to tell the muscle spindles to stop, let the muscle relax. And there's ways that we do this. And that's what brings us to the scientific principles of flexibility. All of this to get us to the point where we can now actually understand the basic process. When you lengthen a muscle, increase stimulation of the muscle spindle fibers. Lengthen it, the muscle spindle fibers become more active. What do? They tell the muscle to shorten. Boom, your muscle tightens up. You know this anytime you try to stretch your muscle. You can only go so far, right? And if you try to stretch your pecs, you're going to get to a point where your pecs, they kind of tighten up on you and you can't move them anymore. Well, what's happening? Well, that's the muscle spindle fiber. The muscle spindle fibers have become active and they're telling the muscle, don't go any further. Okay. So that's the lengthening reaction. Static stretching then is a methodology for getting the muscle to that point and then holding it. So do you ever wonder why when you're doing your static stretching, you just kind of got to sit there and wait? And after about 30 seconds, 45 seconds, what happens? Well, the muscle spindle fibers start to get desensitized and they slow down their activity and the muscle can lengthen a little bit more. Okay, that's how this works. So static stretching relaxes the muscle. Why? Because after a certain period of time of keeping a muscle lengthened, the Golgi tendon organ now basically steps in and tells the muscle spindle fibers to slow down, right? Reduce the frequency of action potential stimulus, right? Just slow it down. And as the muscle spindles do that, it's kind of like lulling the monster to sleep, right? It's kind of like the Golgi tendons are singing and the muscle spindles are, you know, kind of going like this, and they allow the muscle to lengthen. Now, as the muscle lengthens a little bit further, they wake back up and they go, whoa, 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 wait a minute. And they tell the muscle to contract again. And if you do this over and over, and you basically hold the stretch position and you allow it to sit there, you'll have this increased neurological drive on the muscle spindle fibers, and then they relax and the muscle lengthens, and then they act up again and the muscle contracts, and then the muscle lengthens. And this takes at least 30 seconds up to a minute. And so static stretching requires a good amount of time. You can't do static stretching, you know, in 2 minutes. Static stretching, to be done properly, to truly affect the muscle, requires a good amount of time. So figure 1411 basically explains this to you. The goal ultimately here is to understand the scientific rationale for flexibility training. So the concept of pattern overload, cumulative injury cycle, these are all part of and parcel to what happens when we go through our normal regular life and we don't stretch and we don't train, and we allow for these chronic positional changes to occur in our skeleton that then causes muscle imbalances, altered reciprocal inhibition. You can see how the cycle works. And then you have minor but yet chronic cumulative injury. So, and then of course there's Davie's law, which is good to remember. It just states that soft tissue models along the line of stress. Basically, models means that it will start to lengthen and shorten in an altered way according to the adhesions that develop inside a muscle, which is what you're seeing in figure 1413. And these are what are known as trigger points, right? We get them. All I got to do is this, and ooh, got a trigger point right there, right? It's like that little nodule, that little knot. Well, really what that is that's a point, those are areas where muscle fibers, grouping of muscle fibers, have shortened, but they did not lengthen. So part of the reason we stretch statically is to get those areas of hypercontracted muscle fibers, right, to relax and lengthen. And when that happens, the muscle tends to feel a little bit better. You don't have that feeling of stress or those little areas. And that's that's important that you let your clients understand that. They know that. It's one of the reasons why I used to, particularly for athletes, tell them to get massages, because that allows and relaxes the muscle, gets rid of those trigger points. Of course, the techniques that we use are self-myofascial techniques, one of the best, quite honestly. And you'll notice it's funny because when I first started doing this, we did not have foam rollers. We're talking a long time. In fact, I don't even remember having stability balls and Bosu balls when I first started, but we did have baseballs and tennis balls, and that's what we used to use. And basically what we were doing was using a concept of this idea of autogenic inhibition, right? Autogenic inhibition, if we can get the Golgi tendon organs to activate, become active, right? And one of the ways you do that is by applying pressure to the muscle. Those Golgi tendon organs, after about 30 seconds, they kick in and they tell the muscle spindle fibers to slow it down, and the muscle can stretch and relax. That's what this self-myofascial release technique does. You can do it with anything. Foam rollers are great. Look, don't be rolling back and forth. Foam rollers were not meant to be done like this. That is not what foam rolling is, right? Unfortunately, they use the term rolling, foam rollers. And so people thought that, well, I guess I should be rolling. It's kind of like kneading dough. Your muscles are not like dough. No, the idea of the foam roller is to get to the point of tenderness, right? That's why the tennis ball works so well. I can take a tennis ball, can literally put it on my shoulder or on my pec or on my back, and I can find that area of tenderness, and then I compress it a little. I put the pressure on it. You got to do that for about 30 seconds. When that happens, you will actually literally feel the muscle relax and it lengthens. Okay. Again, a technique like this takes time during a training session, if you're going to even do it during a training session. But if you are, that's the idea. That is one of the best ways to really get the muscles to lengthen and relax, which is really critical to help with muscle imbalances. So normally you're going to do this on those overactive shortened muscles, just as a for instance. So Now, of course, from page 452, here are some techniques that you can use. There are precautions and contraindications. Got to be really careful, by the way, when you're doing this. And then you can read through, obviously, some of these other tables. They can be very helpful. If you do try to memorize them, it's going to be a fair bit of work to do that. Then you have static stretching. Static stretching, again, this idea that if we lengthen a muscle, once you get to a certain length, the muscle is going to try and protect itself. Muscle spindle fibers activate and it contracts. Static stretching then is designed to get to that point and hold it. When you hold it, the Golgi tendon organs will start to become more active and the muscle spindle fibers will start to deactivate, so to speak. And when they deactivate, the muscle is able to lengthen a little bit more. And then there's just this constant process of lengthening, contraction. Lengthens a little bit, stretches. And that's the idea, excuse me, of static stretching. And boom, now we're into just page after page of techniques for stretching particular muscles. Not a bad idea to try them yourself. Look, when all is said and done, if you want to memorize this, you got to do these yourself. And you should be able to do these off the cuff once you start training people, when you go through the stretching components of a workout. Then there is active stretching. And we use active stretching to pull in the reciprocal inhibition. You notice we haven't talked about reciprocal inhibition, but active stretching used to be called active isolated stretching. Active stretching is a way of lengthening muscles, but without it taking 2 to 3 minutes of time. You can actually do active stretching and do it in, a third of the time. It literally takes 5 to 10 seconds to get that same lengthening out of a muscle, but you're using the neuromuscular system in a different way. You're kind of tricking the muscles. Now, remember we talked about reciprocal inhibition. It always involves 2 muscles, right? Static stretching and foam rolling work on autogenic inhibition, right? One muscle. So I have to work on that muscle, right? But active stretching uses the neuromuscular system through the reciprocal inhibitory process, which involves two or more muscles. So basically what I'm doing with with active stretching is as I choose the muscle I want to stretch. If I want to stretch my bicep, I'm going to be using my tricep to lengthen my bicep. And all I have to do to lengthen my bicep more than it's accustomed to is I simply get it to a point where it's stretched, and then I do what? I contract my tricep. Remember what reciprocal inhibition is. The contraction of the agonist relaxes the antagonist, okay? So just think about that for a second. If you want to stretch your hamstrings, what's the antagonistic muscle group to the hamstrings? It's the quadriceps. So you would get into whatever position you're going to get into, and you're going to, say, lean forward and go do a toe touch to stretch your hamstrings. And now you're going to get to a certain point where, boom, your hamstrings are just not going to be able to lengthen anymore. Guess what happens if you try to contract your quads at the same time? You will literally be able to go forward. Why? Because of reciprocal inhibition. And that's what active stretching allows for. And by the way, it only takes a couple of seconds. Literally, you contract the muscle, you contract 1, 2, relax, and you'll find that the hamstrings in that case would allow you to lengthen more. Really pretty cool. Again, a bunch of pages of the actual techniques. Dynamic stretching and controversial stretches. Yes, dynamic stretching, again, uses reciprocal inhibition because you're now moving a limb, right? And you're contracting a muscle, right? Dynamic versus static. Static, no movement. Dynamic, right? You probably have seen this when you're standing up and you're doing toe touches, where you do your kicks up and you touch your hands out and you do one leg at a time. Well, you're trying to stretch your hamstrings and your glutes while you're doing that. It's called dynamic stretching. I use it very, very rarely. I don't do it with individuals that are detrained. Always do it with people that are in fairly good condition. But dynamic stretching is another way of stretching. In the case of the kicking your foot up and touching it with your opposite hand. You're trying to stretch your hamstrings. You're simply using not only the movement of the limb itself, but you're also using the reciprocal inhibition. And again, now we're talking about, you know, all these other different exercise opportunities and other stretches. We get to the end of the chapter, of course, and read through your summary chapter highlights. And again, great chapter. A lot of good material in there. Flexibility training, very important, and enjoyed going through it with you. And remember, I will see you on chapter 15.